Group theory, properties of groups. One of the properties of groups is the reversal law, also known as socks and shoes property. This property states as if A and B are the elements of group G, then inverse of AB equals B inverse into A inverse. Here the binary operation dot on group G is taken in multiplicative sense, though it is not an ordinary multiplication. Now we prove this property. Since G dot is a group and A, B are its elements, we have that A inverse, B inverse are also elements of group G. Let X be the inverse of AB, then by definition of inverse, we have AB into X equals E, we number it as 1. Here an element E is the identity element of group G. Next we pre-multiply equation 1 by A inverse. So after pre-multiplying equation 1 by A inverse, we will have A inverse into ABX equals A inverse into E. By associativity, this implies A inverse A into BX equals A inverse. This A inverse A becomes identity, so this implies A into BX is equal to A inverse. That means BX equals A inverse. Next we pre-multiply this last step by B inverse. So after multiplying this last step by B inverse, we get B inverse into BX is equal to B inverse into A inverse. Associativity else B inverse B into X equals B inverse into A inverse. Again this B inverse into B becomes identity, so we write E into X is equal to B inverse into A inverse. That means X is equal to B inverse into A inverse. But this X was taken for the inverse of element AB. So here actually we proved that the inverse of AB is equal to B inverse into A inverse. Thus the reversal law is proved. That means socks and shoes property is proved. Now we see the reason why this property is known as socks and shoes property. For that, suppose we assign A for putting your socks on, B for putting your shoes on, then clearly A inverse is for taking off your socks, B inverse for taking off your shoes. So inverse of AB is nothing but taking them off, means take off your socks and shoes. Now this can be done by taking off shoes first and then socks. You cannot take off socks first and then shoes. So inverse of AB is equal to B inverse into A inverse. So what do you think about this beautiful property? Here the source of the name of this property can be found in Gallian's book Contemporary Abstract Algebra.